Hello AP friends. In this video I'm going to go over these two trickier U-sub problems that I gave to you just because they use that different kind of U-sub technique that we learned in our last Hun Zoom class. So if you already completed these two problems, go ahead and zoom ahead. You can try to find my answers, but if you were really stuck, here are my steps. Okay, for number 13 folks, when I look for my inner function here, I look at the x minus 2 instead of the x plus 2. X plus 2 doesn't really have any operation on the outside, so it's not really a good choice for an inner function. So I'm going to choose the x minus 2. Alright, off to the side, I'll call u equals x minus 2. And I'll go through all the same steps as we've been doing so well before. Okay, I'm ready to do my substitution in. I'll substitute in for dx, and I'll substitute in for x minus 2. Alright, this integral is going to turn into the integral of x plus 2 times the square root of, well, x minus 2 was my u sub, so I'll call that u. And then over here, dx equals du, so times du. This looks really good, but as we notice here, the x's are not canceling. So we have lots of u's here, which are good, but the x is not canceling. That's bad. So what we did in class last time, if you remember, if you get slow with this, go back to your U-substitution and let's solve for x. If u equals x minus 2, can you solve that for x? I would get x equals u plus 2. Okay, now what if we took this, since that is equal to x, and we'll substitute it in here for this x, which will hopefully give us all u's here. Alright, let's see what happens. This turns into the integral of not x plus 2, but u plus 2, and then plus the 2 that was already there. And this looks good. We have all u's here, so we're doing great. Let's just simplify. This becomes the integral of u plus 4 times the square root of u du. We're ready to take the antiderivative, but it's a little messy, and we've got a bit of a product rule here, and we don't really know how to undo product rule, so maybe the best thing to do first, like we learned before, is why don't we go and distribute so you get a single polynomial here. Alright, I get the integral of, well, if you think about square root of u is the same thing as u to the 1/2, then when I multiply in, I can just add my powers. This becomes the integral of u to the 3 over 2 plus 4 times u to the 1 over 2. And this becomes a little bit easier now to take the antiderivative of. Okay. Integral goes away. I'm going to add my powers and do the reverse power rule. And I get about 2 over 5 u to the 5 over 2. That's the first one. Plus 8 over 3 u to the 3 over 2. And then, of course, this is indefinite, so we definitely need the plus c. If you remember that, bravo, proud of you. Good job. All right, but we can't end here, right? Because we need to plug the x's back in because he's indefinite. So let's see, what was our original u? I think our original u substitution back up here on top was x minus 2. So I'll plug that back in. And he'll go plugged into both places. And folks, there's my final answer. So again, the reason why this was trickier is because when you did your normal steps for u sub, you got stuck right here. And you realized that I could not eliminate the x's, so, well, we had to rewrite our u substitution in terms of x, substitute back in, and then go forward as usual. Now, if you wonder, you can go and take the derivative of this, and it's going to take a little bit of factoring magic to get back to the original, but it really, really does work. But go ahead and give it a try and see if you get the original back out if you take the derivative. But this is the answer for number 13. All right. Why don't we move on to number 14? If you've already tried this one, or you're brave enough to try it now on your own, go for it. Pause my video here, and then just come back. Okay, let's try number 14, guys. Again, lots of things going on here. I do have an x that's inside a square, so he's kind of an inner function. And I also have an x minus 4 that's also inside a square root, so that's also an inner function. But I think the x minus 4 is going to be a little bit better. And you could try either way, but I think if you try the top, you'll get stuck. So we'll have to come back to the beginning anyway. All right, so I'm going to call my u the x minus 4 that was on the inside. Same steps, folks. All right, so let's plug everything back in and see how it looks. X squared over, this is the square root of u now, and dx becomes du. There we go. Again, we're stuck though because the x is not eliminating. We're a little bit tricked here. So like we did before, let's go back up to the top. Let's take our u substitution and solve for x. If u equals x minus 4, x equals u plus 4. And we'll take that, which is equal to x, and plug it in here. Ready? Here we go. This becomes the integral of not x squared, but u plus 4 squared over the square root of u. This looks good. All right, we got all u's here. That's very, very nice, very pretty. It's not easy to take the antiderivative yet, so we're probably going to have to simplify a little bit here. All right, well, if that squared wasn't there, we could probably just divide each piece by the bottom and simplify there, but there is a squared, so we're going to have to square it out. I'm going to write the square root as this. All right, so now let's go ahead and divide each piece on top by the term on the bottom, or some of you like to bring the bottom up and multiply by the negative power. Either one's fine. But this would look like this for me. Basically this. Sorry to run off the page there. All right, how about a little simplifying here? Subtracting our powers, we get basically u to the 3 halves plus 8u to the 1 half plus 16u to the negative 1 half du. That looks better. Now we can take the antiderivative. It's not going to be easy, but it's still doable. I'm just going to move over here a little bit. All right, the antiderivative, let's add our power, do the reverse power rule, and I get, how about 2/5 u to the 5 halves plus, this looks like 16/3 u to the 3 halves, and then plus 32 u to the 1 half plus c, because it's an indefinite integral. All right, maybe I'm going to take the derivative of that really quick in my head just to make sure I got the right antiderivative, because that was tricky with some of those fractions. So feel free to do that really quick, and then we'll come back in. Let's plug our u back in, about 2/5. Now our u up here was right up here, x minus 4, right on the top of the page. So if that's x minus 4, then we can plug that in for our u. And like on the other problem, friends, you could take the derivative of this and see if you get the original expression inside the integral, but it would take a little bit of factoring magic to work out. But it does work out. But there you go. Those are the two tricky problems because you have to do a special kind of u-sub with the x's instead of just the u's. Good job. Well done.